Okay, so today we're looking at the definition of a logarithmic function. I'm talking about logarithmic functions in particular. So if x and b are positive real numbers such that b does not equal 1, then the log base b of x is called the logarithm function base b, where y equals the log base b of x is equivalent to b to the y equals x. So given y equals log base b of x, the value of y is the exponent to which b must be raised to obtain x. The value of y is called the logarithm, b is called the base, and x is called the argument. The equation y equals log base b of x and b to the y equals x both define the same relationship between x and y. The expression y equals log base b of x is called the logarithmic form, and b to the y equals x is called the exponential form. Now let's look at this. So I have log base 3 of 9 equals 2. And it wants us to write each equation in exponential form. Well, this is simply equivalent to 3 to the second equals 9. Okay, how about the log base 6 of 1 equals 0? Well, this is equivalent to 6 to the 0 power equals 1. Okay, we can go to in the other direction as well. Write each equation as in its logarithmic form. 10 to the 4th equals 10,000. This is equivalent to the log base 10 of 10,000 equals 4. Or I can even have something like this, 1/8 to the negative 2 equals 64. This is equivalent to the log of 1/8, or log base 1/8 of 64 is equal to 2. So next we have what's called the equivalence property of exponential expression. It says if b, x, and y are real numbers with b greater than 0 and not equal to 1, then b to the x equals b to the y implies x equals y. So now we can evaluate these expressions. What is the log base 5 of 125? Well, 5, if we set this equal to y, we have 5 to the y power equals 125, and y equals 3. Likewise, if we have log base 3 of 81, 3 to what power equals 81? And this is y equals 4. Also, the log base 4 of 1 over 64, if we set this equal to y, then 4 to the y power equals 1 over 64. The 4 to the negative 1 power is 1/4. 4 to the negative 2 power would be 1/16. The 4 to the negative 3 power would be 1/64. And there we go. Okay, next up we have what's called common and natural logarithms, which you've probably seen these. The logarithmic function base 10 is called the common logarithmic function. Common logarithmic function is denoted by y equals log of x. Notice that the base 10 is not explicitly written. So essentially, the log base 10 of x is the same as this, the log x. It's understood that the base is 10. That's called common logarithm. Then the logarithmic function base e is called the natural logarithmic function. The natural logarithmic function is denoted ln of x, and this is the same as the log base e of x. So with these two things, we can use these and calculate these on our calculator. We can find the natural log of 10 million. If you look on your calculator, there should be an log button. Simply hit it and plug in our 10 million, and you should get 7. We can take the natural log of 87. This isn't going to come out even, but we can still do it. In this case, you're going to need to hit the second key and then the log key. And you'll note that it's an ln up there in yellow. Oh, wait, no, my mistake. There is a natural log key on these calculators. ln. Hit log and hit 87. And I get 4.4659, and it keeps going. How about the log, natural log of e to the 5th? This is where we're going to need to hit the second key. To get e to some power, you hit second and then the ln button. So we hit ln, we'd hit second, we'd hit ln, and then we take it to the 5th power. And of course, this is just going to be 5. You can do that for anything with a common log, which is base 10, or the natural log, which is base e. So some quick looks at this. The basic properties of the logarithm. The log base b of 1 is 0. We saw that earlier. Because 1 to the 0, or anything to the 0 power is 1. The log base b of b is equal to 1, because b to the 1st power is equal to b. So the log base b of b to the x is simply x, and b to the log base b of x is x as well. So let's look at this. Let's do some examples here. So we have log base 13 of 13. Well, that's simply log base b of b here. That's equal to 1. 13 to the 1st equals 1. Or 13 to the 1st equals 13. How about the log base pi of 1? Well, this is simply 0, right? Pi to the 0 power is 1. How about a to the log base a of 3? Well, that meets this one here, which is simply 3. How about the natural log of e? Well, remember the base. So we're still looking at this, which is 1. How about e to the natural log of 6? So second, ln e to the natural log of 6. And we hit ln again, 6, close in parentheses, enter, and we should get 6, which would be this right here, right? So again, natural log and common log we can do on our calculator. So let's look at an exponential function. Exponential function is going to look like this. With this point here, oops, backwards, sorry. So let's see, try this again. So we're talking exponential function, and we're looking at y equals 2 to the x. And when okay, so when y is 0, or when x is 0, y is 1. So we're looking at, actually that's not what we're, let's just look in general. So we had this function here, which is, and we had this function here. These are our exponential functions. This one is for b greater than 1. This one is for b between 0 and 1. And you can see the point 0, 1 right here. A logarithmic function is going to look like this or like this. This one here is for 0, b between 0 and 1. This one here is for b greater than 1. And this point here is 1, 0. So you can see that we replaced x with y. These two are inverses of each other. So let's see. Okay, so let's look at g of x equals the log base 3 of x minus 4 plus 1. So let's find some points on this. X and y. Well, if x is 7, this is 3. The log base 3 of 3 is 1. Okay, so we end up with 2. If this is 5, the log base 3 of 5 minus 4 of 1, that's 0, right? Oops. Plus 1. We can't go negative. So let's see, what about let's see, 9? No, not 9. How about 13? This would be log base 3 of 9, which would be 2 plus 1 or 3. So let's regraph this. So we're looking at 1, 2, 3, 4, 5, 1, 6, 7, 2, 8, 9, 10, 11, 12, 13, 3. And we're basically looking at a vertical asymptote here. That's how we graph these. Okay, there's more examples of this in the text. So let's look at this. So the intensity of an earthquake is measured by a seismograph, which is a device that measures amplitudes of shock waves. I sub 0 is a minimum reference intensity of a zero level earthquake against which the intensity of other earthquakes may be compared. The magnitude M of an earthquake of intensity I is given by M equals the log of I over I sub 0. Okay. Now it says determine the magnitude of an earthquake that is 10 to the 5.2 times I sub 0. So what we're looking for is our magnitude is 10 to the 5.2 times I sub 0 over I sub 0. So the I sub 0 is canceled out, and we have the log of 10 to the 5.2. Now I have a log. This is a common logarithm, base 10. So this is simply 5.2. And that's how you can tell the magnitude of a hurricane. So that finishes up section 4.3. And we shall see you next time.